You know, another great way of proving two triangles are congruent is the ever-popular angle-angle side. Now, the angle-angle side congruence, sometimes abbreviated AAS, says that if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So let's check out the picture here. What that's saying is, if I have one angle, pair of angles corresponding being congruent, and then two others, and then this side, angle, angle, side, then in fact the triangles are congruent. Angle, angle, side. You see how I go around and read it off? Angle, angle, side, congruent to angle, angle, side. Therefore, there's a new method that we can use to prove two triangles are congruent, which is especially handy when we know something about two angles and then the side that follows. Let's take a look at some examples. So here is a figure, and we're given a bunch of information and we're asked to prove a theorem. So let's see if we can actually prove this. So what's given here? What's given here is the fact that angle Q is congruent to angle S. So I'm going to mark that in here in green. And angle QRP is a right angle, as is angle SRP. So in fact, both of these angles are right angles. They both have a measure of 90 degrees. And finally, that's it. We're supposed to prove that triangle PQR is congruent to triangle PSR. How can we do it? Well, look, this is crying out for angle, angle, side. Because I have angle congruence, and look at this side. That side is shared by both. So the line segment PR is congruent to itself by the reflexive property. So I have angle, angle, side, congruent to angle, angle, side, and therefore these two triangles are congruent by angle, angle, side. Awesome.